So welcome everybody. This is 7.2 on the addition and subtraction formulas. This does go into your ID bank, your identities bank. So today's essential questions are: how do we use the addition and subtraction formula to get the exact value of a trig function? That's what we are going to talk about today. And the next lesson, we are going to talk about how do we use these formulas to help us verify or prove identities. Okay. So before I introduce the new formulas, I want us to make a list of what angle measures we do know the trig functions for. So without using a calculator, what angle measures do I know that the trig function is for? $45 degrees, okay. What else? We're gonna spend some time listing out all of them, which is 5, 9, 17 of them. We got one, so 16 left. 30, okay. I know how to get the 30-degree angle. What else? 60, 60 degrees. What else? 90, okay. Yeah. 180. Yeah. 270. What else? 120. Okay, what else? 360. So without using a calculator, we can get the sine, cosine, trig, or tangent function, right, of 45 degrees, of 180 degrees, of 270 degrees. What other angle measures? Well, if you know 360, then you know 0, right? Because they're the same angle. 225, we do know. Okay. Huh? 135. 150. Yes. What else? This is quadrant 1, right? This is quadrant 2 with the quadrantal angles. This would be quadrant 3. This would be quadrant 4. So what other angles do I know in quadrant 3 and quadrant 4? Quadrant 1 and quadrant 2 are done. 210. Okay. What else? 240. Okay. Quadrant 3 is done. Now go on to quadrant 4. We only got one there. We need 3 more. 300. 315. And 330. Right? These are all the angle measures that we do know the trig functions for. Okay? We also know the radian measures of all of these angles, right? So let's take about 2 minutes to try and fill them out. Okay, get the radian measures of all of these angles. Okay? So here is the list of all the degree measures and the radian measures, okay, of all the trig functions that we do know the angles measured for, right? So the sine of 150, we can figure it out without using a calculator, correct? Yeah, just for example. So this is what we're going to use to kind of figure out. Now, what if I ask you to find the cosine of 75 degrees without a calculator? Okay. In your assignment, they're gonna ask you to find the exact value. Calculators are never, ever, ever going to find the exact value. I mean, if it's a whole number, then yes, but most likely cosine of 75 degrees is gonna be a decimal, right? So you're gonna eventually have to round. That's not finding the exact value. Okay, so whenever you see the exact value, that means you can figure it out without using a calculator. Okay, all right. So finding the exact value is the same thing as without a calculator. Cool. So we have these formulas here, the addition and subtraction formula, to help us figure out the exact value. Okay, and then we're gonna derive it. Okay, that's why we have these addition and subtraction formulas to help us figure that out. What is the cosine of 75 degrees? Okay, and to help us memorize or remember these formulas, we're going to memorize these two phrases. Okay, it's sine can't change signs and crazy cosine switches sign. All right, so to work with the first one, sine can't change signs, that phrase is talking about the addition and subtraction formula for sine. So let's say we have sine of two angles, x plus y. So the two angles is x and y, right? So how can sine can't change signs? How can this phrase help us memorize the formula? The first letter in this phrase, right, in each word in this phrase is important. SCCS, right? So I'm going to write it down here. SCCS. S always stands for sine. C always stands for cosine. Okay? Sine can't change signs, the whole phrase. Since sine can't change the signs, if this is a plus, this is also going to be a plus. We are going to be multiplying these two values. Okay? And what we're going to do with the angles is we're going to alternate them. X, Y, X, Y. That's the formula. Okay? Sine can't change signs. SCCS, they can't change it, so that's a plus, so this is a plus. And then just alternating the angles. Okay, so that's the sine formula for addition. The sine formula when you're subtracting two angles, x and y, sine can't change signs. I know we're going to be multiplying the two. S stands for sine, C stands for cosine. It can't change the sign, so if that's a plus or that's a minus, this is also going to be a minus, and then alternating the angle measures. Cool? Yeah? That's how sine can't change signs help us derive the formula. Okay? Questions on that? Sine can't change signs. And now cosine is crazy and it switches signs, right? Crazy cosine switches signs. So if I want the cosine of two angles that we're adding together, again, the C stands for cosine, S stands for sine. So crazy cosine switches sine. C stands for cosine, S stands for sine. I know we're multiplying them together. Addition, and it's crazy, so it switches. So that's a minus. Yeah, switch the sign. And then alternating my angle measures again. Okay. And to get my difference, crazy cosine switches sine. Again, S stands for sine, C stands for cosine. Since that's a minus, this is going to be a plus because it's crazy. And then I know I'm going to be multiplying them, and it's going to be alternating my variables or my degrees or my angles. Okay? X, Y, and X, Y. Cool? So that's how sine can change signs, and crazy cosine switches sign help us to get the formulas. All right? And I put the formulas here as well. Okay? And then formula for tangent, I'll talk about that in a little bit. Okay? What I memorized is I'm going to be adding or subtracting the two angles together, the tangent of the angles together in my numerator. And I know it's 1 minus 1 plus or minus the product. That's what I memorized. Okay? And we'll talk about how we do that in a little bit. But here are the formulas. Okay? Questions on the formulas. So now, going back to my original question, what is the cosine of 75 degrees? Without using a calculator. Remember our first activity? We got all of these angle measures that we do know that trig functions for, right? Ready for a basic math question? How do I use these numbers here? Add or subtract to find 75. What two numbers, when you're adding or subtract them, give me 75? Any combination works. Okay. 30 plus 45, right? 30 plus 45 is 75, correct? Yeah. So I can go to cosine of 30 plus 45. Give me one more example of what I can do or what I can use. I can go cosine of, yeah, 135 minus 60. I like it. Okay? It doesn't matter what combination you use. Okay, you'll get the same answer anyway. Okay? Does that make sense? As long as you get a sum or difference of 75, you're good. Okay? All right. So if it's the cosine of 30 plus 45, I'm going to derive my formula. right? Cosine, so crazy cosine switches signs. So crazy cosine switches sine. S stands for sine. C stands for cosine. I know I'm going to be multiplying. Since that's a plus, I know that this is going to be a minus. And then alternating my two angles that I picked out. If it was this one, I would go cosine, cosine, sine, sine, minus, this is going to be a plus, 135 times 60, 135 times, and then 60. Right? So both of these guys work. Notice the difference. This is a plus and this is a minus, and they'll offset each other. Okay, somehow, somewhere they will offset, and we will end up getting the same answer. Okay, so I'm gonna be working with this one. So now it's just the activity of what is the cosine and sine of 30 and 45. If you don't know that off the top of your head, go back to the basics, right? What I mean by that is if it's 30 that we're interested in, draw it out. I know it's in the first quadrant, right? If that's 30, that's 60, right? That's 90. Opposite the 30-degree angle is, what's the value here? 1. Opposite the 60-degree angle is? Rad 3. Opposite the 90-degree angle is? 2. Okay? It's very basic, right? Cosine of 30 and the sine of 30. What's the cosine of 30? That's x over r. Or if you want to go really back down to your foundation, adjacent over hypotenuse. Same thing, square root of 3 over 2. Sine of 30, y over r. Or again, if you want to go back down to your foundation, then it's opposite over hypotenuse, right? 1/2. Yeah? If we do the same thing with the 45-degree angle, it'll still be in my first quadrant, right? 45, 45, 90. Opposite the 45-degree angles are 1. Opposite the 90-degree angle is square root of 2. So I gotta get the cosine of 45 and the sine of 45. What is the cosine of 45? Rad 2, square root of 2 over 2. They're both the same, right? Square root of 2 over 2, right? Yeah. So that's it. And now we just have to plug it in and see what we get. Okay? So the cosine of 30, that's square root of 3 over 2 times cosine of 45, square root of 2 over 2, minus sine of 30, 1/2, sine of 45, square root of 2 over 2. Multiplying those two fractions, square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4, minus 1 times square root of 2 is square root of 2. 2 times 2 is 4. Since I have the denominators of 4, we can put it together and go square root of 6 minus square root of 2 over 4. That's it. That's the exact value, right? If you plug this into your calculator, you are going to get a decimal, right? Which does not work, okay? You have to put this as the exact value. All right, any questions on this? No? My next example, example 1, cosine of 1 or pi over 12. There you go. You guys missed it out. I will. Okay. So cosine of pi over 12. So again, we can think of this at one of two ways. Okay, if you guys, how do I get pi over 12 using these radian measures? Who likes fractions? For the video, there is no hand up right now, but mine. I don't even like fractions. So there's no hand up in the classroom, right? So what can we do? I don't want to deal with radian measures. I like numbers. What can we do? Yeah, we can convert this radian measure into degrees, right? So to convert pi over 12 into degrees, we are going to multiply that by 180, right, over pi. Or we could just plug in pi for 180 and just get the same thing, right? Because these two guys cancel out. It's just going to be 180 over 12, which is 15. Okay, 180 divided by 12 is 15. So now we're getting the cosine of 15 degrees. And that's simpler now. Now we can work with it, right? So what is the cosine, or how do I get 15 degrees using the numbers that I know? 45 minus 30, right? 45 minus 30. You can go 60 minus 45. You can go, I don't know. What's another one we can go? 225 minus 210, right? You can use any combination that you guys want, okay? But to keep the math light, I would go with the simplest one, okay? Maybe in a problem, you have to go in the third or fourth quadrant. I'll put something like that on there just for you guys to force you guys to use the numbers here. Yeah. Or it might be a number like 165 and you have to use something bigger, right? But keep the math simple, keep the math light. So I'm going to use cosine of 60 minus 45. Okay, that's 15, right? So cosine of 16 minus 45. Cosine is crazy. Cosine switches sine. So sine, sine, cosine, cosine. Multiplying them. Switches sine, so it's minus. So that's plus. Alternating my degrees. Okay. So if I wanted to draw a 60-degree angle, I'll get something like this. 60, 30. So opposite to 30 is 1. Opposite to 60 degrees is square root of 3. Opposite the 90-degree angle is? Yes, it's 2. So getting the cosine of 60 and the sine of 60. Cosine of 60 is 1/2. Sine of 60 is square root of 3 over 2. We know the cosine and sine of 45 because we already did it, right? So cosine times cosine, that's 1/2 times square root of 2 over 2 plus sine of 60, which is square root of 3 over 2 times sine of 45 is square root of 2 over 2. And then we just going to multiply. 1 times square root of 2 is square root of 2 over 2 times 2 is 4 plus 3 square root of 3 times square root of 2 is 6 over 2 times 2 is 4. I got the same denominator of 4 square root of 2 plus square root of 6. Okay? Cool? Questions? Okay. So we have 3 more examples. Okay? One sine, one tangent, and another one. Sine of 15. I already did the math for 60 and 45, right? Yeah, and again, you can use whatever one, okay? So keep it simple, but just because I want to, and I want to show you guys something different, right? I want to show you guys something here. I'm going to do 225 and 210, okay? Because that is 15 still, right? Yeah? So I want to show you that it doesn't matter which one you use, 225 and 210. So the sine of 225 minus 210, right? That's 15. So sine can't change signs, so sine can't change signs. Sine, cosine, cosine, sine, minus, so that's a minus 225, 210, 225, 210. All right. So 225 is in my fourth quad or my third quadrant. I want to make it like that. All right, that's 225, right? Yeah. So that's 45, 45, 90. So opposite the 45 is 1, opposite the 45 is 1, opposite the 90 is square root of 2. But since I'm in my third quadrant, everything x and y are both negatives. Okay? So getting the cosine of 225, getting the sine of 225, that one would be cosine of 225 would be negative square root of 2 over 2. Both are negative square root of 2 over 2, right? Yeah. Okay. That's 225. 210. 210 is still in my third quadrant. It's a 30-degree angle, like here. So opposite to 30 is 1, opposite to 60 is square root of 3, opposite to 90 is 2. They're both negatives because I'm in my third quadrant, right? So having the cosine of 210 and the sine of 210, cosine of 210 is square root of 3, negative square root of 3 over 2. Sine of 210 would be negative 1/2, right? Okay? And then if you guys missed it, cosine and sine of 225 is that. All right? So now, again, we just plug it in and we see what we get. So sine of 225 is negative square root of 2 over 2 times cosine of 210 is negative square root of 3 over 2 minus cosine of 225 is negative square root of 2 over 2 times sine of 210 is negative 1/2, right? So negative square root of 2 times negative square root of 3, that's positive square root of 6 over 2 times 2 is 4, minus negative square root of 2 times negative 1, that's square root of 2 over 2 times 2 is 4. So that's square root of 6 minus square root of 2 over 4. And that is your answer. Cool? Yeah. So you can use big numbers as well, the big degree measures as well. Tangent of 165. So first step, how do I get 165? How do I get 165? Yeah. 225 minus 60. That would work. Yeah. Tangent of 225 minus 60. Okay, let's do that. So that is the tangent of 225 minus 60. Now, when you guys study up on the formulas, you guys will find this trend. Okay. I know in my numerator, I'm adding or subtracting the tangent of both the degree measures. Okay. On the bottom, or my denominator, I know it's 1 plus or minus the product of the two. That's what I memorized. This template right here is what I sat down and I memorized. Okay. Adding and subtracting. 1, adding or subtracting the product. Okay. And we're dividing it together. Now, how I remember if it's plus or minus these signs, right, is going back to what tangent is. What is tangent in terms of sine and cosine? Looking at your identity sheet, right? Tangent equals sine over cosine, right? And I know the sine and cosine addition and subtraction formula. The sine can't change signs, and crazy cosine switches signs. So in my numerator, since tangent equals sine over cosine, and since sine can't change signs, I know this one can't change. And since crazy cosine switches signs, I know this one switches signs. Okay? That makes sense? Yeah? I use sine over cosine to figure out the operation. Cool? Now it's just the activity of what is the tangent of 225 and 60. Okay, so 60 degrees first. That's in my first quadrant. That's 60, 30, right? So across the 30 is 1, across the 60 is square root of 3, across the 90 is 2. What is the tangent? That's y over x, or opposite over adjacent, which is square root of 3, right? So tangent of 60 is square root of 3. Okay? 225, I already drew in my my previous example. That's 1, 1, red 2, because this is a 45-degree angle. That's negative and that's negative. So tangent of 225 is 1. Negative 1 divided by negative. Right? So that's 1. And we just go. And the hardest part about this, you guys will find out in a little bit, but it's simplifying it. Okay, it's not actually getting these trig functions, but it's simplifying it. So let's go ahead and plug it in. Tangent of 225 is 1 minus tangent of 60 is square root of 3 over 1 plus the product of the two, which is square root of 3, right? Okay. But notice that I have a denominator, or I have a square root in my denominator. Okay. So what I need to do is, just like our example that we did, yeah, previous to the lesson, a plus b times a minus b equals, I'm going to use the difference of squares to get rid of them. Okay, these, if you guys don't remember, these are called conjugates. Okay, they're just the same terms, 1 and square root of 3, a and b, multiplied together, but the only difference is the plus and the minus, right? But that comes out to be a squared minus b squared. So if you square the square root of 3 squared, right? The square root goes away. And that's the point of this. I want the square root to go away. Okay, so I'm going to be multiplying this by be multiplying this by 1 minus square root of 3, right? The conjugate of that, 1 plus square root of 3. Okay, so in my denominator, I know it's going to be 1 squared plus, or minus, I'm sorry, square root of 3 squared. Okay, in my numerator, I have 1 minus square root of 3 times 1 minus square root of 3. That is just 1 minus square root of 3 squared, right? Yeah, because I'm multiplying it by itself. Do you guys remember that formula to quickly multiply that out? If you guys don't know, I'll write it up here. A plus or minus b quantity squared equals a squared plus or minus 2ab plus b squared. The plus or minus goes, if that's a plus, that's a plus. If that's a minus, that's a minus. Okay? That sign will just follow. So I'm going to be using this special formula to simplify this out. Okay? So a squared is 1 squared, which is 1, minus 2 times 1 times square root of 3 plus square root of 3 squared, right? All over 1 minus 3. Okay? So simplifying the numerator first, this is the 3. If it's square root of 3 squared is 3. So it's 1 plus 3, which is 4, minus 2 square root of 3 over negative 2. Correct? Everybody with me so far? From here to here? I simplified somewhat along the way. Okay? Now, what can I take out of a 4 and a 2 square root of 3? A 2, right? But since that part is negative, I'm going to take out a negative 2. Okay? Because I want to cancel out the negative 2 down here. Okay? So here, if I take out a negative 2, the positive 4 becomes negative 2. The negative 2 square root of 3 becomes a positive square root of 3. Make sense? Yeah? And now these negative 2's, they would cancel out. And you're just left with, I'm going to flip it, square root of 3 minus 2. You can leave it as negative 2 plus square root of 3 as well. Okay, both of them works. All right. Okay, so that is the tangent of 165. This one to this one. Okay. So I'm going to put in another step in here. So that's 1. That's minus 2 square root of 3 plus square root of 3 squared. That's plus 3, right? So 1 plus 3 is 4. And then minus 2 square root of 2, or 2 square root of 3 is minus 2 square root of 3. And then 1 minus 3 is negative 2, right? That's how I got negative 2. Okay? Okay, so my last example here is we're working backwards. So you have to think backwards. Find the exact value of the expression sine 20 degrees times cosine 40 degrees plus cosine 20 times sine of 40. Okay. So I know that we're multiplying sine and cosine, right? So that reminds me of the sine and cosine functions of addition and subtraction, right? Those formulas, right? So what I do is, okay, it's S, C, C, S. I know sine can't change signs. I know crazy cosine switches signs, right? Sine can't change signs. Sine can't change signs. This must be a sine formula, right? It can't change the sign. So if that's a plus, this is also a plus. And the two angles that I'm dealing with is 20 and 40. Does that make sense? Yeah. So sine of 20 plus 40 is 60. So what is the sine of 60? You can draw it out. We drew out a lot of triangles today. It's square root of 3 over 2. Okay? That's it. Just recognize the formula and work backwards. All right? Sometimes it'll be like the tangent formula, which it's easy to spot. Cool? That's the lesson for today. Thank you very much, and I'll see you on the next one.